Hello class, my name is Desmond Edagese and I welcome you to your favorite math class. Today we'll be looking at the theme mensuration and geometry, and our topic for today is bearing. Now here are the things that we will be learning today in our class. So first, we'll get an introduction to what bearing is all about. We'll also know what cardinal points are. We'll find how to locate object positions using bearings. And finally, we'll learn how to find the distance between objects using scale drawing. It promises to be an exciting class. Are you ready to begin? Let's go on. Now, bearing, the word bearing, what does it mean? In mathematics, bearing refers to the direction of an object from a point. The direction of an object from a point. It is measured as an angle in degrees, always in a clockwise direction from the north line. Now, the instrument used to find bearings or direction is called what? A compass. We make use of compasses in finding bearings or directions. Wherever you are, you can find the bearing or the position where you are relative to someone else or something else by making use of a compass. Let's go on to learn more about bearing. Now, the compass that is used in finding bearings, is based on a circle. The circle, of course, is a rough depiction of the earth. The earth that we know is circular. So we need to find positions of people or things within the frame of a circle. So a compass is also shaped in a circular manner, and finding bearings using the compass is also done in a circular manner. Now, a typical compass is marked or has points that are marked on it called cardinal points. These points are what we really use in finding the bearings or direction. This, again, is a depiction of our compass, It is round in shape because the earth is also round. And on the earth, we can find the northern part of the earth, the eastern part, the southern part, the western part. So also, the compass is marked and it is pointing in the various directions of the earth. And the markings within our compass, they are called cardinal points. The major cardinal points within a typical compass, they are the north, just like we mentioned earlier, the east, the south, and the west. These are called the major cardinal points or the primary cardinal points. Now we have other cardinal points that are not the major ones, They are called the minor or secondary cardinal points. They are the northeast, so we have the major as north, south, east, and west. While the minor or secondary cardinal points are the northeast, as the name is northeast. It's a combination, because it is in between the north and the east. So we have that as one of our minor cardinal points. Also, we have the southeast, which is also located between the southern part of our compass and the eastern part, southeast. Next, we have the southwest. The southwest also stands in between the south and the west. So we have the southwest as another minor cardinal point. And finally, we have the northwest. So these are all the primary or the major cardinal points along with the secondary or the minor cardinal points. Now let's take a look at our diagram here. This is the map of our country, Nigeria. It shows the major cardinal points. So we have the north. Of course, we know that the Hausas lived in the north. We have the south, where we have states like Rivers State, Calabar, and all of that. We also have the east, where basically we have the Igbos living there, and we have the west, where we have the Yorubas living there. So that's an example of a map containing the major cardinal points. Also, to find the cardinal point by yourself as an experiment, if you don't know where the northern part, if you are standing or if you are facing the northern part, wherever you are, okay, just take note that from geography you learned that the sun rises in the east and sets in the west. So wherever you see the sun rising from, okay, generally that is the eastern part of where you are. And wherever you see the sun setting into, you have the western part. Now, if you are standing on the eastern part, that is the part where the sun is rising, and you turn 90 degrees, what do? You will face the north. So from the east, turning 90 degrees, you will face the north. That part that you are now facing is the north. So that's another easy way, okay, to locate the north. Also, from the north, if you turn another 90 degrees, what happens? You'll be facing the west, where, of course, the sun sets. From the east also, if you turn 90 degrees to the right, in this case, in the other case, we're turning 90 degrees to the left to face the north. If you turn from the east, where the sun is rising, you turn 90 degrees to the right, you will be facing the south. So these are easy ways, okay, to find the northern part of where you are, the southern part, the eastern part, or the western part. Now let's go on. We have an image here that shows two compasses. Remember, the compass helps us to find direction or position of where you are. All right, so our image shows two compasses with positions A and B. The compass, okay, will always have the red part or the major part of our compass facing north. It always faces the north. So our two compasses here faces the north, as we can see. Now the compass at B is in a direction of the northwest to A. A is our reference point, okay? We say that the compass at B is what? At a direction northwest, that is in between the north and the west. So if A again is our reference, B is what? At a direction northwest. It is in between the west and the north. In the same way, the compass at A, if B becomes our reference point, this compass, okay, is in a direction, what? Here we have our south, here we have our east. So the direction here, of course, is in between the east and the west. So we say in this case that it's in a direction southeast. For our other case here, it was in a direction northwest. So these are ways in locating object positions, okay? We make use of our compass and we determine what position they are by looking at the compass. Our compass here tells us that this position of this object is calibrated as northwest, northeast, southeast, and southwest. So it will tell us exactly where it is, if it is west or east or south or north, or the northeast, southeast, southwest, or northwest. Our object here is in the position southeast to our object in B. In general, basically, bearings can be stated in two ways. The compass acute angle bearing and the three-figure bearing. So again, in general, bearings can be stated in two ways, the compass acute bearing and the three-figure bearing. We're going to learn more as we go on in our class. Now, the compass acute angle bearing, or the compass bearing method, we'll take a look at first. In the compass bearing method, the bearings are given as acute angles measured from the north or from the south. So, of course, we've seen that we have the north, the south, the east, and the west. Of course, and we learned that if we turn 90 degrees, from the east, we will be facing the north. At every division, you have an angle of 90 degrees. So in maths, we say we have 4 quadrants, the divisions of our directions. Okay, this is one quadrant, all of this. This other part is another quadrant. This is a third quadrant, and this is a fourth quadrant. The quadrant is spelled like this. Okay? So each of these quadrants has 90 degrees angle. 90 degrees angle. Now, in finding directions, the angle in between each quadrant is always an acute angle. So you have angles, once is less than 90, even if it is 89, that's an acute angle. Okay? Even if it is 1 degree, is also an acute angle. So acute angles, basically, are angles between 0 and 90 degrees. In using the compass bearing method, we make use of these acute angles, and they are measured from the north. So you take our measurement from the north or from the south. We'll take a typical example. Look at our directions or our bearings here. If you are asked to find the point A from O, okay, what do? We see that A is in the quadrant, okay, that is this part here, where the north is holding ground. So we know that our measurement will be from the north in this case. We'll take our measurement from here. And of course, that was 58. So what do we say? We say our direction is what? 58 degrees, correct? But where exactly? It is in between the north and the east. So we write that as north 58 degrees east. North 58 degrees east. This is making use of the compass bearing method. So we've pinpointed our object to be what? 58 degrees, yes, but it is in between the north and the east, and we write it in that manner. Let's take a look at our other points here. If we have an object D here, and you are asked to find D from O. O is the origin, the reference point there. Find D from O. Again, check. It is within this quadrant here, okay, where the south holds sway. So again, we find that we take our measurement from the south, and it was given to us as 40 degrees. So we have our direction as 40 degrees, but where exactly is it? It is in between the south and the east. So we write that as south 40 degrees east. South 40 degrees east. Let's try another. We have an object C, and you've been asked to find or locate the direction of our object from O. Remember again, our quadrant, it is in a quadrant, okay, where the south is holding forth or is holding sway. So again, we say that our measurement will be from the southern pole. So we take our measurement there. But take note that from the southern pole down to our point C, we don't know what that is. What was given to us, okay, was 30 degrees. So what is this angle which we are interested in? Because our measurement must be from the south. From the south down to our point, this line marking our point C, we don't know what it is, but we know the other remaining parts of the quadrant to be what? 30 degrees. Of course, we know that each quadrant is 90 degrees in size. So if we know this part to be 30 degrees, since it's divided in two, this part will be 90 minus 30. I would have 60 degrees. So it means that our point C, the direction will be what? 60 degrees. But in this case, it is in between the south and the west. So we indicate south and west. We say south 60 degrees west. Take note that our northern and southern poles always come first when we write the direction. So you always have an S or an N coming first, okay, while the other direction is written at the end. So in this case, we have south 60 degrees west. Let's take a last one. We have an object at point B, and we've been asked to find the direction of B from O. O is our origin. In this case, again, it's in a quadrant where the knot, okay, is holding fourth. So we say, measuring from the knot, we have 18 degrees directly. So we have 18 degrees north west. So we have north 18 degrees west. This is how we make use of the compass bearing method. We'll take some quick examples. Take a look at our diagram here. State the bearing of the point P from O in the origin. The point P from O in the origin. The position of our point P from O is what? 90 minus 70. Why is that? First, determine what quadrant it is in. Of course, like we just saw, we saw that it is in this quadrant here where the south is holding sway. Therefore, our measurement will be taken from the south to our point. So we take that measurement. All right? The angle formed there is unknown. But the angle formed on the other half there is 70. But we know that for each quadrant, we have 90 degrees angle in size. So what do? We simply say 90 minus 70 to get this other part is 20. So we have 20 degrees. But the direction is what? Southeast. So we write that as south 20 degrees east. Quite simple. Let's take another example again. State the bearing of the point P from O in the diagram. So we have a point P. Determine again the quadrant, okay? Within our quadrant here, S, the south is holding sway. So we take our measurement from the south to our point P, the line of our point P. We don't know what this angle is, okay? But we know that in a typical quadrant, we have 90 degrees angle in size. So if all of the angle is 90 degrees and half of, or a part of that is 15 degrees, this part, x, which we find, will be 90 minus 15. Which gives us what? 75 degrees. So therefore, we have 75 degrees. But the direction is in what? Between the south and the west. We indicate that by saying south 75 degrees west. Very simple. Now let's take two more questions. State the bearing of the point P from O in the diagram. Remember we said first determine which quadrant, okay, is in play. So we have our quadrant here where N, okay, is in charge. It means that we will take our measurement from N. We measure that down to our point P in question. That angle is unknown, but we do know this angle here to be 20 degrees. We said angle in a typical quadrant is 90 degrees. Therefore, our unknown angle is 90 minus 20 degrees that we know. And that gives us 70 degrees. So we have 70 degrees, and our direction is in between the west and the north. So we write that down as north 70 degrees west. Quite simple. Let's take another one. State the bearing of the point P from O in the diagram. Again, our quadrant, okay, is at that point where N is also in charge. We take our measurement from N down to our point P. That angle is unknown. The known angle there is 25 degrees. Therefore, our known will be total angle in a quadrant, which is 90 degrees minus 25 degrees. And that gives us what? 65 degrees. It is located in between the east and the north, and therefore we write that as north 65 degrees east. And that's our answer. So far, we've learned how to make use of the compass bearing. Now we'll learn how to make use of the three-figure bearing. All right? In the three-figure bearing method, bearings are given as the number of degrees measured in a clockwise direction from the north only. In the compass bearing, we measured from the south or from the north, but in this case, we're measuring from the north only. Any direction can be expressed in 3 figures alone. Take note, figures alone, no letters, figures alone. So for angles less than 100, zeros are written in front of the digits. Let's take a typical example. The direction east in 3 figure bearing is indicated as 0, 9, 0. We have 3 figures there. This is one figure, this is another figure, this is a third figure. So we always have 3 figures. And we don't have letters. In the other case, we had north, we had angle, and then we had another direction. In this case, we don't have letters, we only have figures or numbers, and there are 3 of them. So we have 3 figures in the 3 figure bearing method. Again, the direction north is written as 0, 0, 0 degrees or 360 degrees. Remember, we said a compass is shaped in a circular manner, just like our Earth is circularly shaped. So when you take the measurement of degrees in a complete circle or a revolution, you have 360 degrees. So our north, okay, beginning the count of our angles could be either 0, 0, 0 degrees, and in completion of that revolution or turn could be 360 degrees. So the north is always depicted or shown to be what? 0, 0, 0 degrees or 360 degrees. Any of them can be used. For the west, we have 270 degrees. It's depicted as 270 degrees. Remember, at each point, you have a 90 degrees difference. So if you have 0, 0, 0 here, you have 90 degrees difference here, plus 90 degrees difference here, plus 90 degrees difference here, and plus 90 degrees difference here. Each quadrant is 90 degrees in size. In the same way, the south is 180 degrees. Moving from the east to the south, you add 90 to get 180 degrees. From the south to the west, you add 90 to get 270 degrees. And from the west to the north, you add 90 to get 360 degrees. All right? So this is how we write in the 3 figure bearing. Let's take another example. The 3 figure bearing for north 37 degrees east. The compass bearing name is north 37 degrees east. But in the 3 figure bearing method, that is written as 37 degrees. And we write that as 037 degrees only. Let's take a typical picture of what we mean. The 3 figure bearing here, okay, taking our measurement from the north, we have 37 degrees exactly, and it is in between the north and the east. Using our compass bearing method, we will say N 37 degrees east. In the 3 figure bearing method, we simply write the 3 figures, which are 037 degrees. And that's that. On the other hand, the 3 figure bearing name south 66 degrees west. Okay, this is how it is on our diagram. 66 degrees. Okay, it's in this quadrant where S is holding sway. And measuring from our south, S will have 66 degrees. We'll write that as S 66 degrees is in between south and the west, west. That is how we would write it using the compass bearing method. But in the 3 figure bearing method, we said measurement is taken from the north only. From the north only. So we take our measurement all the way from the north. That's 90 degrees. That's 180 degrees. And then plus our 60 degrees added here. 180 degrees plus 60 degrees gives us 246 degrees. So we write that in 3 figures, 2, 4, 6 degrees. This is how this is written in the 3 figure bearing method. Of course, in the compass bearing method, what we meant to write is south 66 degrees west. So these are the 2 ways of indicating the same direction. South 66 degrees west is the compass bearing method of writing that, while 2, 4, 6 degrees simply is the 3 figure bearing method of writing the same direction. Now let's take a typical example of a three-figure bearing method. Find the three-figure bearing of A, B, C, and D from X in the figure below. So our measurement is taken from S. We have a point or an object, A. We say find the three-figure bearing from X. So how do we do that? In three-figure bearing, remember, you take your measurement from the knot only, and you write the figures of your measurements as figures only without letters in 3 digits. So let's go ahead. The arrow N, of course, is indicating the knot, so you know exactly where to take your measurement from. Therefore, NXA, this angle or this point, is simply 63 degrees, taking measurement from the north. So you have that to be 0, 6, 3. You don't just say 63 degrees, okay? You add the 0 at the end to make sure you have 3 digits, okay? So you have 0, 6, 3 as the direction. Next, to find the point B, this angle here was given to us, okay? So, but how do we find the direction of the point B from our point of origin here, X? What do? We take our measurement from N, the north. This is the angle that we desire to know. It is unknown, we don't know what it is, but we know what this angle is here, 35 degrees. We know that the angle on a straight line, that is directly from the north to the south, is 180 degrees. So if we know this small part to be 35 degrees, the remaining part will be what? 180 minus 35 degrees. And that gives us 145 degrees. So we have 145 degrees as our three-figure bearing. Check our 3 figures are indicated 1, 4, and 5. So it's a 3-figure bearing. So next, let's find the 3-figure bearing of our point C. All right, again, our measurement is taken from the knot only. So we go the whole distance. That we have to be 180 degrees. That's half of a full turn. And then plus our angle there. Now that angle is given to us to be 75. But what we are interested in is the full turn from the knot down to the line of our point C in question. So we have 180 degrees. Moving from the north to the south, we got 180 degrees plus 75 degrees given to us. And that gives us what? 255 degrees. That is our 3-figure bearing. It has 3 figures, 2, 5, and 5. So we don't need to add a 0 to that. We have the 3-figure bearing of our point C to be what? 255 degrees. Let's find the 3-figure bearing of a point D. Again, measurement is taken only from the north. So we go the full distance. We have 180 degrees. At this point, remember we have 270 degrees. So we have 180 down to 270 and then down to our angle there, which we do not know. So basically, a full turn would have been 360 degrees. Less this little angle here, we'll have the remaining of our turns from here down to the north. So simply say 360, which is a shorter method, minus the 52 degrees that was given to us, and we'll get, okay, our 3-figure bearing from the north down to our point D. 360 minus 52 is 308. So we have our 3-figure bearing of the point D to be what? 308 degrees. Now let's take 1 or 2 examples. Example 1, if the bearing of X from Y is 247 degrees, find the bearing of Y from X. Find the bearing of Y from X. Okay? So in this case, we have 2 points, and we need to find the bearing of 1 point from the other. What do you do in such a case? Okay, no diagram is given to you. You have to sketch your diagrams from understanding what the question says. The bearing of X, so you have a point X, from Y is 247 degrees. So basically, you have Y, Y is the reference point. From Y, you have a point 247 degrees away from Y, you will get X. So let's assume that to be our knot. Taking from the knot, 247 degrees. A full or half of a turn, remember, is 180. Not up to 270. Here is 180, 270, and of course 360 here. We have 90 there. What has been given to us is 247 degrees. So we take a turn, 180. We'll go on, but it is less than 270. So let's just say it's in between, can approximate. There you will find the point X. We draw a line, and then we mark X there. So let that be our X point. Now you have an understanding of what has been asked of us. If the bearing of X from Y is 247 degrees, from Y, the word from Y tells you that Y is the reference point. So get your angle 247, draw your line, and then you find the position of your X. So you have your X located there and your Y somewhere there. Now you've been asked to find the bearing of Y from X. So now they are telling you that X now is your reference point. What is the bearing of Y now from X? Okay? Now there are two ways to go about this. From our image here is a better diagram than what we've drawn so far. Just drew this so that we better understand. From Y, we had that angle 247 degrees where we trace our line to find X. This line indicates our northern point for Y and another point for X. So what is the bearing of Y from X? That would be taking your angle from the knot. Remember, you're taking from the knot down to that line. So what is this angle? Theta. That is the bearing, okay, of Y from X. To get this angle, all right, since these northern lines are straight and parallel. Parallel means they never meet. Okay, they could continue being projected upwards and never meet at any point. They are parallel. All right. To find our angle here, we can simply say, if we mark that, we'll find that taking our measurement from N1 here would have 180 degrees on this full length and something else left here. So what is this angle here, from here to here? This angle, let's say theta 2, will be what? 247 degrees. All of this is 247 minus angle on a straight line. We're talking about this angle to this point here, okay, is what? 247 minus 180 degrees. Here you have 180 degrees, so therefore what would this theta 2 be? Theta 2 is 247 minus 180 degrees, and that is 67 degrees. So our angle here is 67 degrees. Our theta 2 is 67 degrees. Now, in geometry, these angles here are theta 1 here and our theta 2. They are what? Corresponding angles. And they are equal. Corresponding angles are equal, especially since our lines here are parallel in nature. They will never meet. Therefore, the angle they create, okay, at this point and at this point are corresponding angles and they are equal. So theta 1 is equal to theta 2, which is what? 67 degrees. And 67 degrees is what we are interested in as the bearing of Y from S. That is this angle, 67 degrees. Now that's one way to look at it. Another way again is if we indicate, okay, that line and say, remember again, from the knot down to this point was 247. So from the knot down to this point, that's a straight line, is 180 degrees. So what would this side of the angle be? Again, it's 247 minus 180. We also have 67 degrees. Again, this angle here, let's call that theta 3. Theta 3 and theta 1 are also equal. By the laws of geometry, they have a relationship where they are called alternate angles. So you have an angle something like that, where these angles are parallel in nature, theta 1, theta 2, they are equal. In the same way, also, theta 1 here, theta 2 here are also equal. This is corresponding angles relationship, and this is the alternate angle relationship. So in either case, we come to the same answer, 67 degrees. So our bearing of y from x is 67 degrees. Next, we'll learn how to find distance between objects using scale drawing. Now you can use the knowledge of bearing that we've learned so far to find distances between two or more objects. Before now, all we've learned about is to find the location or the direction of objects relative to one another. But then you can find the distances between them, not just the points where they are, not just to locate them, but to actually find the distance between them. To do that, using scale drawings, okay, we'll be making use of our rulers. So if you have a ruler at home, you can bring out your paper, take a ruler and a protractor. We use our rulers to measure the distance, and the protractor we use to draw our angles. Okay? To find bearings and locate distances between two or more objects, follow these simple steps. So whatever your question is given to you, what do? Understand the question first and try to sketch the information you get from your question. Next, select a scale, because the typical question may be in kilometers, miles, and so on. But of course, you can't draw kilometers on your paper. Your paper is quite small compared to the distance that may be given to you in your question. So you select a scale, all right? Use that scale and then get a ruler to measure out your scaled drawing. Now, in the course of your drawing and sketching your information, you will easily see where the unknown that you've been asked to find is. Join the unknown points and then use your ruler at the end of the day to measure it. Your unknown points, okay, will be indicated on your paper. We'll see that in an instance, how these simple steps can be followed in a question. Now let's take this question. A student starts to walk from point A and he walks 3 kilometers east. So of course now we know our cardinal points. We know where the east is, we know where the west is, where the north is, where the south is. You can just draw a rough drawing. Let's not look at our image on the board here. Let's start from scratch. A student starts from point A. Let this be your point A. And it says he walks 3 kilometers east to B. Okay, so from A to B, he walks 3 kilometers. Remember, we are walking east because you have the north, the south, the east, and the west. So you are walking towards the right-hand side. You are walking east. So you draw that on your paper. That distance was given to us to be 3 kilometers. Now, she then walks 5 kilometers, okay, on a bearing 152 degrees from B. So she has walked from point A to B. Now she is walking again from B. She's going somewhere else. She's going somewhere else at a bearing of what? 152 degrees. So from our knowledge of bearing, we know that from B, we also have the north, south, east, west. We know that each quadrant, that is the 4 divisions, are 90 degrees in size. So we know this to be 90, we know this to be 180, 270, 360, and so on. Here we've been told that she moves at a bearing of 152. So it's beyond 90, but it's less than 180. So it's somewhere here. Draw a line, she moves in that direction. So we have a new direction. From B, she's moving downwards. Okay? Now it says that she reaches a point C. So the next point she reaches is point C. The distance and the bearing of this C from A. She started from A, moved to B, and then got to C. Now we've been asked to find the distance from C to A. So what do? We draw that line, that distance. We need to find it. We also need to find not just the distance, but the bearing. What is the bearing, okay, of our distance from C to A. So, like we said, we'll make use of what? Our ruler and our protractor. And we'll be scaling things because what we have is in kilometer, but on paper we can't have a kilometer. So we've been able to draw a rough sketch. First, we said sketch the information. We've sketched. Now let's scale. The next point says scale. Scale. We have 3 kilometers, but we know that we can't use kilometers in our paper. So what do? We say 1 centimeter, let 1 centimeter represent 1 kilometer. So let 1 centimeter represent 1 kilometer. So instead of saying 3 kilometers, what we actually will measure physically with the ruler is what? 3 centimeters. Because 1 centimeter in our scale is representing 1 kilometer. We have chosen this scale to make it easy for us. So on our paper, we may write 3 kilometers, but we use our ruler here, okay, to measure out 3 kilometers. All right? Now that that is measured, the next distance she walked was what? 5 kilometers from B to C. Also from our point here, where you've measured the last 3 kilometer point, measure another 5 kilometers. But the measurement of that kilometer we cannot get until we use our protractor. Of course, you know your mass set. Take your mass set. Your protractor is used to measure angles. So you place your protractor on this point, okay, and you measure out 152 degrees. 152 degrees. So place your protractor facing this way. Your protractor faces this way. You measure from 0, it goes round, okay? From your protractor point, you will get it somewhere here, 152 degrees. If you place it, okay, like that, you mark that protractor on your paper there, that point, and then draw your line. That line is 5 kilometers. 5 kilometers. But we are using our ruler, we are measuring 5 centimeters. So on your paper, you may write 5 kilometers, but you physically measured with your ruler to get 5 centimeters. Now, next step, just use your ruler. No need to calculate anything since we're using scale drawings, and measure this out. Use your ruler and measure. What you have is what? 6.9 kilometers. 6.9 centimeters, actually. What you have is 6.9 centimeters with your ruler. But since we're using a scale of 1 centimeter to 1 kilometer, that also means what we have is 6.9 kilometers. All right, so the distance from C to A is 6.9 kilometers. But the bearing of C from A, so A is our reference point. The bearing of this C from A, what will it be? You make use of your protractor again. You place your protractor lying flat in that direction and then take your measurement. You find that the measurement of that angle is what? 130 degrees. From 0 down to this point is 130 degrees. So we have our distance and the bearing of C from A. Let's take one more example. Aba is 116 kilometers on a bearing 027 degrees from Port Harcourt. How far north of Port Harcourt is Aba? How far west of Aba is Port Harcourt? Okay? In this case, you also make use of what? Your ruler and your protractor. Okay? Remember, you need your ruler and your protractor. Again, Aba is 116 kilometers on a bearing 027 degrees from Port Harcourt. All right? So let's L here be our Port Harcourt. Now we're told that Aba is 116 kilometers on a bearing 027. So you place your protractor flat there and you measure out 27 degrees. 27 degrees, you get that point and draw a line. So if here is your Port Harcourt, you'll have Aba at that point. We're told that that distance is what? 116 kilometers. Okay, so that's what we know for now. Now, how far north of Port Harcourt is Aba? This is Port Harcourt, this is Aba. How far north of Port Harcourt? North of Port Harcourt, okay, would be in that direction. North of Port Harcourt. How far north of Port Harcourt is Aba? This is the distance that we want to find. How far north of Port Harcourt is Aba? On the other hand, how far west of Aba is Port Harcourt? So if this is Aba, we know our north, south, east, and west. So the west is towards the left. So how far west of Aba is Port Harcourt? That will be, let's say, y kilometer. Okay, that is the information needed. So we've been able to sketch. Remember we said always try to sketch your information. Sketch the information first. Now we said select a scale. In this case, take a look at our distance, 116 kilometers. Okay, select a scale that is suitable for you, that you can have on your ruler. If your ruler has just 30 centimeters, it means that you need a scale of something like 1 centimeter to represent 20 kilometers. Let our scale be what? 1 centimeter to represent 20 kilometers. Okay? 1 centimeter representing 20 kilometers. It means, therefore, that the actual measurement we measure for 116 kilometers will be 116 over 20. So we have something 11.6 over 2, which is what? 5.8 centimeters. So what you will really measure with the ruler is 5.8 centimeters, but we may write 116 kilometers. Okay? Now we have our scale, we have our sketch. Next point, join the unknown points, LK and IK. Here's our L, here's our K, and here's our I. Join the unknown points. LK was our unknown point. We join it. IK also join that. Now, K is the point due north of Port Harcourt and due west of Aba. That meeting point between the due north of Port Harcourt and due west of Aba is that. LK is the distance that Aba is north of Port Harcourt. What do? We simply take a ruler. We've already measured with our ruler and found from our scale that we have 5.8 centimeters measured here. Next, you're at home, okay? You, my student at home, take a ruler and measure this. That measurement will give you what? 5.2 centimeters. You find that this measurement here is 5.2 centimeters. From our scale, which we said 1 centimeter to represent 20 kilometers, we multiply 5.2 times 20 to give us the real measurement in kilometers. And that would be 104 kilometers. So, how far north of Port Harcourt is Aba? We've answered that question. It is 104 kilometers. Next, we'll find how far west of Aba is Port Harcourt. IK is that distance. The distance that Port Harcourt is west of Aba. We had our I here and our K here. So this distance here is what we seek. Take a ruler again and do a simple measurement. What we have is 2.6 centimeters. So we have 2.6 centimeters here. From our scale, we multiply 2.6 times 20 to give us 52 kilometers. So we have 52 kilometers as the distance between the west of Aba to Port Harcourt. All right? So we say Aba is 104 kilometers north of Port Harcourt, and Port Harcourt is 52 kilometers west of Aba. Wow. We've come to the end of our class today. I'm sure you had an interesting time. But before we go, we'll take a quick recap of all that we have learned. Today we learned about bearing. We say bearing is the direction to an object from a point. We say bearing is measured as an angle in degrees in a clockwise direction from the north line. We said the instrument used to find bearing or direction is called a compass. Okay? Remember, we saw an image of a compass. This is another image of another compass. We said there are 4 major cardinal points, that is markings that are marked on our compass. Those points are north, east, south, and the west. We said in general, bearings can be stated in 2 ways. Either the compass bearing method or the 3-figure bearing method. Also, we learned how to calculate and find distances between different points, making use of our knowledge in bearing. Now, before we go, I want to be sure that you really know how to find bearings. And to do that, I'll give you 2 quick questions to answer, and then our class will come to an end. Now, state the bearing of A from B in the diagram shown here. I'm sure this should be very simple for you. What is the bearing of A from B? We are making use of the compass bearing method. What do? First, we determine which quadrant, okay, we are making use of. Of course, we are making use of our quadrant here, where the south is king, or it holds sway. All right? Next, we know that our measurement, therefore, would be from the southern line to our point in question. What is that angle here? It is not known. But we do know the angle here, which is 50 degrees. We said in a typical quadrant, we have 90 degrees, okay, angle. Now, if we know that to be 90 degrees and we have that to be 50, our unknown there will simply be what? 90 minus 50 degrees, and that gives us 40 degrees. So we know our bearing to be 40 degrees, but what is the exact position or direction? We said it is in between the south and the east. And how do we indicate that? We write that to be south, 40 degrees, and then east. So which of our options gives us the correct answer? Is it A, B, C, or D? Option D is very correct. We'll take our last question. Banjul is approximately 2,000 kilometers from Accra. The bearing of Banjul from Accra is 295 degrees. How far north of Accra is Banjul? Again, from our steps, sketch the information given to you. We are told that we have 2 points, Banjul and Accra. Now, Banjul is 2,000 kilometers from Accra, okay? And the bearing of Banjul from Accra is 295 degrees. From Accra, that tells us that Accra is our reference point. So if that point there is Accra, we are told that 295 degrees bearing from Accra, you would find Banjul. Let's do a rough sketch of that information. We have that to be 180, 270. It's above 270, so it's more than 270, but less than 360. We have that there. To get this angle, please make use of a protractor. Make use of a protractor. So remember on your paper, we have a protractor there. We know that from this end to this end, we have what? 270 degrees, okay? And the whole point given to us was what? 295. So let's say 295 minus 270 degrees. That will give us what? 25 degrees. This little point here is 25 degrees. On your protractor, you can quickly place a protractor on your paper and mark out just 25 degrees instead of the full 295. Okay, we've been able to say we're interested in just this point. So mark out 25 degrees on your protractor and draw the line. So we have that. Let's make that neat here. This point alone that we are interested in is 25 degrees. We've marked that. This is Accra. Okay, and we have Banjul at the other point. Remember, you are doing this at home with a paper, with your protractor, and a ruler. Now, we need a ruler to mark out our distance, 2,000 kilometers. But of course, we can't find 2,000 kilometers on our ruler. It's far longer. So what do? We use a scale. Decide the scale to use for yourself. For this particular question, let's use a scale of 1 centimeter to represent 100 kilometers, because we have quite a long distance here, 2,000 kilometers. So it means that our measurement from our ruler here will be what? 2,000 kilometers given to us, divided by our scale, 100 kilometers. What do we have? 20 centimeters. So on your ruler, take this ruler now and measure out on your paper 20 centimeters. Okay? You have marked it out, but what you are writing is 2,000 kilometers. But what you physically measured is 20 centimeters. So that's a sketch of our question. Now, the next question given to us is, how far north of Accra is Banjul? How far north of Accra is Banjul? North of Accra, if this is our Accra, the north of Accra will be our line there. Draw a line upwards, okay? That is the north of Accra. Now, how far is that north of Accra from Banjul? If Banjul is over here, how far is the north of Accra to Banjul? You draw a line now from Banjul to cut that line coming from the north of Accra. And then you have a triangle like that. All right? Let's remember all of that is 295 degrees. So we have our sketch. We've measured this distance to be 20 centimeters, which is representing 2,000 kilometers. Now, to find the distance that Banjul is north of Accra, quite simple, is this distance here. Let's call that x. The distance that Banjul is north of Accra is this distance from here to this point. And that distance, we quickly just take our ruler. Take your ruler now and measure this distance. What you would have is what? 8.5 centimeters. 8.5 centimeters with your ruler. Now, we have a scale where we say 1 centimeter represents 100 kilometers. If you have 8.5 centimeters, therefore, okay, multiply that by 100, and then we'll get our answer in kilometers. That gives us 850 kilometers. So, Banjul is what? 850 kilometers north of Accra. Let's see which of our options here are correct. Is it A, B, C, or D? Option B is obviously correct, 850 kilometers. Wow, such an interesting class. But unfortunately, we have to come to an end today. In our next class, we'll be learning so much more about other topics in mathematics. Until I see you in that class, remember to always practice, practice, practice until you become perfect in mathematics. Bye-bye for now.